so much for giving your time this evening to come with me on a journey about climate change and climate change education. My name is Siegel. I'm a retired certified financial planner, which you would say, what has that got to do with climate change? And that's a really good question, and I'm not going to answer that question in my talk tonight. Tonight I want to share with you the journey I've gone through in getting to where I am now, where I want to dedicate my life, what's left of it, to educating other people about the climate. It started back in 1980, interestingly, the same year that I went into the financial services industry from social work and education. Because it was a stressful job, I started doing an annual retreat down at Flamingo at the bottom of Everglades National Park, and my favorite spot was campsite 10 in the walk-in campgrounds. You're nodding your head, you know Flamingo. And I put my tent under a beautiful, large, shady Jamaican dogwood tree. And every year I chose the same campsite, and every year I noticed that the shoreline had come back a little bit, and I didn't think anything about it. One year I put my tent up, and the tree was hanging out over Florida Bay with its roots like this, and just a little bit of its butt still on the land. And the next year I went back, and the tree had toppled into Florida Bay. I didn't know what I was seeing. I didn't recognize that I was seeing storm surges or seeing climate change at work with sea level rise at that time. Fast forward to about a year ago when Hurricane Irma went through, and I started really paying attention to what I'd been reading and what I'd been seeing on the news and what I'd been hearing in conversation. I went, you know what? This is far more important for people than figuring out how to plan for their retirement. I got it, that if we don't figure out how to reverse what's going on the planet right now, it doesn't matter how much you put in your 401k plan. And so I have changed careers. So I'm going to invite you on a 15-minute journey with me on what I've learned. We're going to do just the science part of climate change tonight. You'll have me back, and we'll talk about how serious it is and the impacts on the planet. And we will end, the third session will be, what are the solutions? And the solutions are what give me hope and allow me to smile a little bit when I'm talking about this. So let's get right into it. I delight in the out of doors, and I wonder how many of you have had, if you closed your mind, your eyes, and opened your mind again, how many of you have had a wonderful experience in nature? Yeah, okay, if we had more than 32 seconds, I would ask you what that was. Our Earth has 4 parts to it that we enjoy. This is the science of Earth science, and these are the 4 things that, that would make it up. And I would apply these to what you said if we had more time. Some people, a handful of people, still deny climate change. They say it's been forever. The planet has had multiple changes of climate, and that is absolutely true. We've had natural climate variability for millennia, hundreds and hundreds and hundreds of thousands of years. Our planet's about 4.6 billion years old, so that's quite a while. I'm going to talk about what's been happening recently and rapidly. Here's a picture of Earth taken from the space shuttle. The red area is the atmosphere part that we breathe. The black is where we live, and the blue is the rest of the atmosphere. The whole thing's about 6 miles from bottom to top. And it's made up of, interestingly enough, about 1% of carbon dioxide until we've started pouring more and more into the air, and about 21% oxygen, and the rest of it is basically nitrogen and some other kinds of gases. So it's beautiful. To understand what's happening, I want to walk through real quickly what the carbon cycle is. This is a piece of science I would like everyone on planet Earth to understand. The carbon cycle is what has been basically a cycle in balance. We breathe in oxygen and we breathe out carbon dioxide. Animals do the same thing. Trees, plants, phytoplankton, tiny microscopic plants in the ocean, breathe in carbon dioxide and breathe out oxygen. If we don't have enough plants on the planet, we don't have enough air to breathe. A statistic that blew me away was that about 28% of what we breathe as oxygen is produced by the rainforests. About 70% is produced, our oxygen, by the phytoplankton in the ocean. If we don't take care of those teeny tiny little green things that we don't even see when we go swimming in Biscayne Bay, we're dead. So what's been happening is when we burn fossil fuels, if you think about what do you know about gas and oil and coal, it's dead plants and animals compressed for millennia under lots of pressure and heat. And when we take it out and burn it, we release all the carbon that's been, I like this word, sequestered in gas, oil, and coal, and we're letting it out. So we've been obviously burning lots and lots and lots of fossil fuels. We started in the Industrial Revolution about 1850, and since 1950 we've been doing more and more. The carbon dioxide we are releasing from fossil fuels and methane, and I'll talk about that in a minute, looks like this on our planet. The squiggly purple lines is heat coming in from the sun, radiation, solar radiation, and the red is heat gets absorbed by the earth and the oceans and radiates back out. Excuse me. The radiation is supposed to go out into outer space, but when we've got carbon dioxide molecules hanging out in that atmosphere, it's like little Pac-Mans. The carbon dioxide absorbs the heat. There's another gas up there too, methane, that absorbs even more, and I have a little demonstration for you. By the way, carbon dioxide in the atmosphere is very important, or we would be frozen to death. You recognize this from the, yeah. So we need carbon dioxide. The carbon dioxide we need is as thick as this little blanket. What we are doing though, could I get you just stay there for a minute so I can do the demonstration? All the carbon dioxide and all the methane that we are releasing from, and I'll talk about that in a minute where it's coming from, is like bundling this poor little guy under layers and layers and layers of wool blanket. And that's what we're doing to ourselves. Thanks so much. We must have a baby at home.
On the way.
On the way. You're going to do great. So, let's go back 600,000 years. This blue graph on the bottom, and if I had a pointer, I would red dot it, is showing for millennia, thousands and thousands of years, what kind of carbon dioxide level we've had in the atmosphere. And you can see at the low point, we've been about 180 parts per million, and at a high point, any high point until now, we've been at about 300 parts per million in the atmosphere. And that's our green blanket. When it's low, we've had ice ages. When it's high, we've had flooding because the ice caps have melted. Well, look what the current level is now. And last month, the current level was at 408 parts per million. It's too hot. I will be adding a slide that overlays heat on top of the carbon dioxide and sea level rises on top of it. And when I get that from Dan, you will see that all three of them follow each other. There's a big correlation. Where's the carbon dioxide coming from? Well, I did mention burning fossil fuels, and I did briefly mention methane. Animal agriculture accounts for, depending which book I'm reading, 18 to 35% of the greenhouse gases that we release into our atmosphere. Methane is a greenhouse gas. This little green blanket is worth, if it's carbon dioxide, is worth one blanket for 24 hours. Methane, pooped and farted out by cows, is worth 25 blankets for 12 minutes. We're too hot, friends, we're too hot. Energy is the largest consumption of, or the largest, we use the most fossil fuels in generating our energy. And God knows I need air conditioning just like you do. And burning fossil fuels in transportation is another big one. So what's the effect of this? Well, with the planet warming, areas of the northern area of our world have something called permafrost, where the ground is frozen permanently. It's melting. This is a chunk of Alaska that fell into the sea. If you happen to be a Native American, I have to find the right word for it. If you happen to be an Eskimo or an Inuit, and your village has been on the edge of the sea for decades and decades and hundreds of years, you're going to lose your shore. But what's really, really bad for everybody, not just the folks who live there, is the fact that when the permafrost melts, it's also sequestered dead organic matter. And when bacteria have access now to dead organic matter. They eat it up and they release methane. And when I do a longer program, I have a little video of setting fire to methane bubbles in the ice, because the methane is bubbling up out of the permafrost. It's very dramatic. So what's it like for us? You're supposed to laugh. I'm trying for a little bit here. Okay, thank you very much. Okay, well, there's a lot of climate and there's a lot of impacts of that, a heating world, and it's really in the news every day, everywhere, every place. Increased temperatures create more precipitation extremes, stronger storms, more rain, stronger flooding, more drought. I did not understand myself, why would the same thing cause both flooding and drought? But it does make sense. If you think about it, with things heating up, moisture comes out of things that are wet, like the sea, and things that have water in them, like our soil. And so when things get hotter, water evaporates faster. More water in our atmosphere holds more heat and creates more rain. Pretty dramatic. Okay, this is really astonishing. Miami is at the top of the list of 10 cities subject to asset loss due to sea level rise. And I have a map that I want to make a slide of, because I've dotted each of these other cities. And Miami and New York are the only ones in our half of the world. So we are a first world country in the United States. We have second-class citizens, but we have third world problems. No one in Miami is safe. I think we all get it, even if our own house is high. I'd like to talk about the other impact of heat. We talked about where does the carbon dioxide and methane come from, and I'd like to do a little bit of sharing with you what happens, especially here when we're on the coast. Florida used to be very wide. During the ice ages, when a lot of the ocean is absorbed into the polar ice caps. If I said Miami, I meant to say Florida. Florida was 300 miles across, not 80. When the ice caps melted in those times when the planet got hot, we were subject to just a little bit of dry land. The state of Florida, the way it's shaped right now, is only about 10,000 years old, but it's what we've got. So what's happening? Why are the seas going up? Because Arctic glaciers are melting, and they're melting not just from the heat of the sun on the top. They're melting because when sunlight hits the water and the water is dark, it absorbs heat, and that heat comes up under glaciers and melts them from the bottom. So when this first became talked about, that the polar ice caps are melting, and they were first doing projections, they didn't get that it was going to melt more quickly than they thought. This is what the base rock of Florida is, South Florida is. It's limestone with a lot of holes in it, not a good barrier to water. And what's happening is water expands when it gets hot, so no surprise. What's happening with the United States alone, and you can see all the red areas, 17% of our habitable landmass is on the coast, 53% of our population live on the coast. So there's a lot of people in trouble. Sea level rise, depending whose numbers you're using, could go, and I would have the clicker, the light, go as high as a 5'10" person. It's coming, it's here. And the other issue with the rising seas is saltwater intrusion. If you remember the pretty sculpture of limestone rock with the holes in it, it's not a good barrier to seawater coming in. So the salt water is coming into the fresh water that we drink. In 4th grade, if you were here in 4th grade, you learned the word aquifer. That's the big pools of water under our limestone, in our limestone sponge. We just sink a pipe and take fresh water out. Coral Gables wellfield was contaminated a long time ago, and there's conversation now about extending the 836 expressway, which God knows people in Capital need traffic relief, but we don't need it at the expense of our drinking water, so everybody should go to the county commission next Thursday, the 27th. This Thursday, the 27th, and speak out against extending a highway over our last great deal of fresh water. I know I'm out of town, but I'd like you just to appreciate appreciate with me our coral reefs. I'm a scuba diver. I learned about 4 years ago in late middle age, and I love scuba diving and I love our reefs. And I just want you to see what's happening to coral reefs because of excess carbon dioxide being absorbed into the ocean. There's not enough phytoplankton to eat up all the carbon dioxide that's coming in, and so anything that's made of limestone is disintegrating. So it's not just corals, it's things you enjoy. Anything with an exoskeleton, I like that word too, with a calcium exoskeleton. So lobsters, stone crabs, shrimp, crabs, kind of need your help. Thank you very much. I'm available for any questions.